your day?
Well, thank you, Gertrude. It was very nice. Allison? Victoria? Victoria?
Oi.
Okay, so we have a very special lesson planned today. I think you are going to enjoy it. It's a very special one because we are complex numbers. And it's fun because we get to use our imagination.
Yeah, imagination is fun.
That's right, Gertrude. What about you, Victoria? Come on, you can do it, Victoria. 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 Victoria!
Imagination.
Thank you. And you, Allison?
Oh, wow.
Come on, Allison. It's only 2 seconds.
Fun, imagination.
So, we've already worked with square roots in this class. Like the square root of 4 equals 2. And even simpler, the square root of 1 equals 1. But what happens when we get this?
You're an idiot. That can't be done.
Huh. Maybe so, but we can do it through imagination. Because this equals the central concept of complex numbers, I. I stands for imaginary number. Since I is the square root of -1, obviously I squared equals -1. I cubed is equal to I squared times I and comes out to -1. I to the 4th is the same as I squared times I squared, which equals -1 times -1, and therefore equals 1. What's going on back there?
Mr. Squeeze, she's being a retard.
Now, loaded words. I to the 4th, as we said, equals 1. So I to the 5th is essentially 1 times I, which obviously just equals y. I to the 6th is like 1 times I squared, so that would just equal -1. I to the 7th is also 1 times I cubed, so that would just be -I. And I to the 8th is just I to the 4th times I to the 4th, so once again we end up with 1. Now it's simple enough to do something like I to the 5th, or I squared. But what do we do if we get I to the 29th, or even I to the 100th? Now it looks difficult like this because you have to think I times I times I times I times I times I, but it's really a lot simpler when you break it down using I to the 4th, because you remember that I to the 4th equals 1. Therefore, any exponent of I divisible by 4 will make it simply equal 1. For example, I to the 29th can be broken down into I to the 28th, which is divisible by 4, times I to the 1st. That, in turn, just becomes 1 times I, or I. A lot simpler than I to the 29th. With I to the 100th, it's even simpler because it's already divisible by 4. So, it's just 1. Now who can tell me if this... Gertrude, I haven't asked you the question yet.
Yeah, but I already know the answer.
Well, let me just ask it, Gertrude. Now, who can tell me what the standard form of a complex number is? No one? No one at all besides Gertrude? No one?
I know.
Go on, let the door.
No.
Well, maybe I'll just explain it this time. Now, the standard form for a complex number is A plus BI. Keep in mind these aren't all variables. I is still the number that we've remembered, which is the square root of -1. A is a real number. b is simply a coefficient for our I value. So, for example, we can have 3 plus 2i. If a equals 0, for example, 0 plus 2i, we simply get 2i. If b is 0, then we can get 3 plus 0i, or simply 3. This is just the basic format for expressing a complex number. Now, who did their homework last night?
I did.
You? I know you did.
Just me.
No one else.
Just
No?
me.
Well, how would you like to explain to the class how to add complex numbers?
Okay. Okay. So an example would be 8 plus 2i plus 2 plus 3i equals, so you combine the like terms, so it'd be 10 plus 5i. Answer.
Very nicely done, Gertrude.
Thank you.
Now we can move on to subtraction of complex numbers. It works essentially the same as adding them, except we have to remember to distribute this. So let's say we have 8 plus 2i minus 3 plus I. Remember that you have to distribute this so we don't accidentally say 2i plus I, because that's not going to work. You can rewrite it to make it simpler on yourself. So we can have 8 plus 2i plus negative 3 minus I.